All right, let's start with the most exciting part, in my opinion, which will be setting up a more advanced fracture technique. So if we look at our Voronoi fracture, obviously this is not great, right? I mean, we all know this. It's just some basic shapes here, some basic cutter going on. It technically gets the job across, but we want to make this a lot better. If we drop down an RBD material fracture, this is a node I really like, and it will produce good results for us. If we just go to detail and enable edge detail on it, we can change a lot of the settings here. And this node gives us a ton of control, right? Like if I set this to one level of fracturing, we can increase the height of our noise, and we can actually get some really cool looks out of this with an exploded view. The problem with it, though, is throughout my thorough testing, I found that this node, when used with Unreal Engine, actually causes a lot of crashes. And I'm not sure 100% what the reason behind it is, but I think this node is just really heavy, and there's a lot of problems or a lot of chances for something to go wrong while working with it, and it just causes Unreal to immediately crash, not even send like an error or anything. It just disappears. So that leaves this node out of the question. And so I wanted to find a way to recreate this material fracture, but a lot simpler. And I will actually go ahead and just delete this so we can work on it from scratch. And after we're done with that, we'll look at a demo I've set up too for a different fracturing technique. This was what I was going to originally use, where we're generating some planes and then cutting them. And if we tweak this a bit more, we could definitely get some cool techniques out of it. And I will go through this as a walkthrough with y'all just to share it because it does give cool results and I think there's potential for it, but it's not the technique I want to use. So instead, what I'd like to do is take our Voronoi and use this as our base, right? So this is going to be our base fracture. And the technique I'm going to share, I think, gives a lot of control and a really cool result. And if we take this and we split off the inside group of it, enable this again. This is actually very similar to what our RBD material fracture is doing. I'm going to dive into this because this is actually how I came up with the idea for this. And this is a pretty monstrous node if you've never dived inside. So we need to allow editing of contents of the concrete fracture, which is the version of the RBD fracture we're using. And if we dive in one more level, it's generating these cutter pieces here and then adding noise to them and using that to create a Boolean fracture on our mesh, right? So this is the cutter pieces that this whole thing is generating in here. And I'll walk through this a little bit just to kind of explain where I got my idea from. Yeah, so we're bringing in some points. We're creating some cutter geometry here. This is the real juice of the node. And inside, it's actually pretty complicated what they're doing. So as we walk through this, it's creating a tetrahedron from our input mesh points here. It's creating a tetrahedron from those. And then we are creating a unique shape that we are clipping to our box. And the way that it's doing this is in here, which actually has a pretty large amount of stuff going on. Like we have this compute Voronoi points positions, which has a good bit of vex that I didn't bother to read through. But basically, the final result after all of this code is, well, this shape here, which they're using to Boolean fracture. And so, yeah, we're going to go ahead and recreate that shape. And I realized that it looks super similar to the inside pieces here. So I figured why not just use these as our cutter pieces for our geometry. So with our inside pieces, if we go ahead and clean them up and fix the overlaps on them, I do want to see this go away. I do want to see these overlapping go away. Oh, we need to use a fuse beforehand. That's what I'm missing. Yeah, so this will all be considered one shape now. And then this will now work. As long as we don't delete the overlap pairs, instead of just check this on to fix overlaps. Now this is a correct piece of geometry that the Boolean fracture node will be happy with. We'll consolidate some points too. And that should be good. So we have this. Let's add a divide to it to triangulate it. Just plug this in here. And then I'd like to remesh this. And this will be our density for our detail. So we'll plug this in here. And I'll set this something like 0.1 or 0.05 even. Yeah. And from this, let's go ahead and add a mountain to create our noise for it. And what I'm going to want to do is disable noise along vector, so it's not dependent on the normals for the noises. I'm not really getting a good example of why this isn't a good thing. But basically, we're going to get some artifacting if we have this enabled. And let me go back to my clean and turn off manifold topology only, so it doesn't delete these faces for us. As you can see, it's actually deleting faces that we do want to keep. So yeah, we're dividing it, remeshing it, adding a mountain here. And now that this noise along vector is off, it's like an unbiased noise. So we can just turn down the amplitude and the element size. So like something like 0.1 and 0.3. And so now we're getting a pretty dang close representation of our RBD material fracture. If we hop back inside here and look at the final output of this, I'll disable ghosting. Yeah, so we're getting a pretty similar result now, which is exciting. And we can use this to fracture our geometry now. We'll probably want to promote these to parameters, but we'll do that in a moment. So we can use these pieces here in a Boolean fracture. And these are our cutting surface, and this is our original geometry here. Yeah, okay, so we're getting a little bit of artifacting here where it's not cutting all the way through in some areas. So what we can do is we can scale up our geometry or our cutting planes a little bit, like so. If we get the bounding object of our original geometry, so I'm going to hold Control Shift and click and drag to create a duplicate input. I will increase the padding to like 1.3 or 0.3 should be good on all of them. 0.3. So now we have a slightly bigger object than our original input. And we will use this with a match size here. And we will plug this into this side, and we will enable scale to fit. So now this should be a little bit bigger than our original input object. And you can see that it's fixing that artifacting we're getting. Yeah, and so this is already a great result. So if we do like a for each connected piece on this, we can look at each individual piece now. If I turn on single pass, yeah, we can iterate on through and see what we're getting. Yeah, and I am liking the way this is looking now. So this is a much better fracture than a basic Voronoi, and it's not even too complicated, but I would like to build it out a bit further. Yeah, so that's what we're doing over here actually, is we're creating cutter pieces for it, and then inside this subnetwork, we are basically doing a glorified fast version of a Boolean fracture that's just less likely to encounter any errors. So let's go ahead and set that up for ours, or for this current setup. I will collapse this all to a subnetwork here, and I will call this generate cutters. Okay, and we'll create another subnetwork, and we will call this Boolean fracture, and we'll have this as our first input, or our second input, I should say, and our original mesh as our second input. And I will Control X to bring everything inside of here. And so our second input will be matched to this size. Yeah, okay, so what I'd like to do now is drop down a for each connected piece. And if we had more than just this one box as our input, this is when this for each connected piece would come in handy. And we'll see this happen down the line when we import megascans, because sometimes they come in with multiple meshes that are layered on top of each other. So we'll want to fracture each mesh individually so we don't run into any errors. And so with this, we're going to create a meta import node, which we'll use down the line. Or actually, no, we don't even need that. We just need to create a duplicate of this node. So we'll alt drag and set this to fetch input. And for now, we'll just have this fetch the input of our cutter planes. And what we're going to want to do is convert our object to a VDB. So polys from VDB, or VDB from polygons. Cool, and we'll set this to like 0.05. And then we'll convert this back. So this will clean up our mesh. So convert VDB. Okay. And this needs to be set to polygons. Great. Maybe even 0.01. We'll do 0.03. That'll be good. All right, so now we have a clean mesh, and we're pretending that our cube is more complicated than it is, of course. And I'd like to actually inflate it a little bit more. So we'll do a VDB reshape SDF. And so if we put this in between here, we can actually just inflate our VDB. And I'll just inflate it to be safe to like a value of 5. Yeah, okay. And so now we can actually use this shape here to cut our geometry with. So we're fetching our input on this side. And we will want to create a group from this and plug it in like so. We'll set this to points and enable the bounding object for it. And so right now 100% of this is being grouped. But I think what I'd like to do is actually scale up our geometry before we put it in, which is what we're doing with our bound here. Yeah, so we're scaling it up. And then after we've scaled it up with this match size here, we are going to group all of the points inside of it. And we'll delete everything that isn't inside of it. So we'll use a group promote and promote this from points to primitives. The group name is group 1, and we'll just give it a new name of cutters. Cool. And then we'll use a blast and remove everything that is not inside of our geometry. Delete non-selected. There we go. And the reason we're doing this is just to increase the speed of our Boolean fracture. If there's less points for us to look over, it'll move quicker. So our cutting surface is here, and this is our other surface. Or actually, no, our input is our other surface. There we go. Great. And then we'll want to compile this as well, just to make it a little faster in case we have lots of pieces. So we'll enable multi-thread when compiled. Let's make sure everything inside of here is compilable. Press D and set this to large. Great. I'll delete this too and put down a compiled block. And we'll plug in the bottom here, the top here, and then we can just alt drag and create a second input for it. And let's see, do we get any errors? Yeah, that should be okay. It's just a small complaint, but it looks like it's still working. Yeah, and we're not going to see any speed increases yet, but we're planning for the future right now. And so now we've set up a nice advanced fracture for this look. Let's test it out with changing the scatter amount. So I'll go to our top level here. And visualize this part of it. And we'll set our scatter number to 20 maybe. Amazing. 30. Just stress test it a little bit. What about 50? Or, okay, so yeah, we're starting to get some craziness here. Let's try 200. Okay, so we're getting a little bit of craziness going on. Let's see where that's breaking down and if it's something we should be concerned about or not. So we go to our generate cutters here. And this seems okay, as far as I can tell. Yeah, so we're bringing it in here. Having a Boolean fracture on it. I mean, it could be fine. We'll test it out with an exploded view. And our Boolean fracture should be updating our name attribute on it. Yep. Okay. Yeah, so this looks pretty cool. But we are getting some really small pieces here, which could be fine if we were doing a Houdini-based simulation. But for the sake of game optimization inside of Unreal Engine, I'd like to actually merge these pieces back onto or to the closest piece that's next to it. So this will be like a post process we'll do to it. So I will close this side again, and I'll add another subnetwork, and this will be merge small parts. All right, so when we hop in here, what I would like to do is put down a delete small parts node. And yeah, if we plug our input into this right now, it's actually, yeah, it's just doing exactly what it's saying. It's deleting the small parts of this. So if I set this threshold to like 0.01 and we click invert result, let's also set our mode to area is good. Now we're isolating off all of the small pieces of our mesh. And what I'd like to do with this is create a duplicate of it. And this will be, actually we'll create a reference copy of it. So it's the exact same settings, except we'll Control-Shift-Click to break this reference and then disable invert result. And so now we have all of our big pieces here. And we should pack both of these to be point representations of themselves. So I'll enable the name attribute. We have 76 packed fragments, and we'll do the same on this side. And now what I'd like to do is transfer the name to our packed level here. Same for this side. And then we're going to use an attribute transfer. And we will transfer the closest name from our big piece to our small piece. So if I go to our name attribute here and enable this, now we're getting the closest name attribute from these pieces. And now if I were to unpack it and retransfer the name back over through here, and merge it back with our pieces over here, let's test it out with the for each connected piece. And we'll set this to be by name. So what I'm hoping for, or even an exploded view should be fine, now that I think about it. Yeah, so plug in the exploded view. And I think it's done the job. Let's double check by comparing it to the original input. Yep. So here's our small pieces, and then Control Z. And now it's merging them together because they have the same name attribute, and that's where we're exploding by. And because they have the same name attribute all the way through our pipeline, this should be preserved. And we could even up the tolerance a little bit if we want to merge more small parts together. like 0.03. And you can see as we go up, it'll merge more and more pieces together. It's almost like our RBD cluster, but this is completely size-based. And honestly, these are some really interesting results. You might want to mess around more with just this. But yeah, we'll keep it like so, 0.03. And this will be our output now. Great. So now we have the new updated version. We can go ahead and promote these to parameters. And in the next episode, we'll add a bit more control even to this. Yeah, so we can add a switch. And we could compare these results, right? So here's our fancy fracture here and our Voronoi fracture. And we'll put them both in exploded view too. See how similar they look. So here's Voronoi and Boolean, or custom fracture, I should say. And the pieces are about the same size. It's just their intricacy is a lot cooler in this version. This may be the only piece that I'm not too happy with, but really, if you just change the seed, it should be fine. A final thing we could add is an RBD interior detail. And this will just do pretty much what the name says and add more detail to the inside of our geometry. So we'll put this into an exploded view as well. And we should have an inside group here. So if we change our detail size, you can see it's actually going to start adding resolution to the inside group of our mesh. And then we can change our noise amplitude. And you could push this even further. It's probably a bit excessive because we already do have a pretty cool fracture, but it is just worth noting. And also, it's worth noting that we could do that just on our Voronoi fracture over here and get some pretty cool results. If we just plug this in with an exploded view, you can see it's cool. The only problem is it doesn't change our outside, which is why we have to come up with this custom solution. But yeah, the inside, you can add as much detail as you want to with this node. So I'll keep this over off to the left as an example, as well as our RBD material fracture, and this other custom plane setup here, which I will color to be green, and I'll just collapse this to a subnet. And so this can be some interesting reference if you want to explore it a little bit more. Plane-based fracture. Sweet. So I'll save our scene real quick, and we'll promote some parameters over here. Yeah. I'm actually just going to cut this off for now, and this should be nice and organized once y'all get the final file, but I can't focus with this long wire like that. All right, we'll open up the other side here, go to type properties for it, and let's go ahead and open the parameter window. So we already have the scatter number, and we can actually plug this into our pack here, our switch. And I'll want to create a toggle, and we'll call this enable detail fracture. And I'll copy and paste the name. And so now we should have this nice toggle, and we will put this into our select input here. And let's check it on and off. We need to switch these inputs around too. There we go. So if we look at our result here, we have Voronoi and default. Oh yeah, and then this is also coming through in our final result because it's just our collision. So it's looking a little weird in our final output, but it's necessary for Unreal. Yeah, so we'll probably want control over our cutter geometry. So like the remesh density of it. we'll probably want to promote here. This will be detail size, and we'll set the minimum value to like 0.005, I think. Yeah, because any lower than that, and you're like almost certainly going to crash Houdini or Unreal. We want to promote our mountain noise, amplitude, and size, 2 parameters with Alt middle mouse click. And I'll put this all in a new folder called Detail Fracture. T-U-R-E. Cool. And what else do we want to promote? Noise size is a good thing to have. And the Boolean fracture, I actually don't know if there's too much we even need to have control over in here. Yeah, I think that's it for now. So we click apply. And let's set this to a simple folder type. And test it out now. So where is this explode coming from? Oh, duh. So if we explode it a bit and change our amplitude to like 0.2, we're going to get some pretty crazy looking noise now. If we set it to like 0.05, we get a little bit less noise. And the detail size, if we press W here and lower this to like 0.02, we're going to get some really high density meshes here. I'll set it to 0.1 and we'll get a little bit more reasonable density. Maybe that's a little low. Yeah, and so I would recommend probably adding the RBD detail, interior detail node as well into your setup for even further control. But let's test this out in game and then call this a good episode. So we will save our node type and re-import and rebuild it. And I'm not sure if our fracture region will work or not, but I guess we'll find out. So this is our default fracture. It's creating something okay. We'll enable our detail fracture and cross our fingers. Okay, it looks like it's working. We'll hide our static side and unhide our active side. Yeah, that's great. So we'll go to our fracture mode and explode it too. And look at that. First try. Works like a charm. Cool. So we'll push this a bit further in the next episode. And I'll see y'all there.